Hello learners, welcome to a new video. In this new chapter we will learn about Newton's laws, so let's go start. Here are some concepts that we should keep in mind for this lesson. The forces and their effects. Whenever there is the intervention of a force, there is at least an interaction between two bodies. For example, a soccer ball. It must be kicked by a soccer player to move across the field. Or this apple that falls down to the ground. The first body is the apple, but what is the second body? Write in the comments if you know the answer. The effect of a force depends on its magnitude as well as its direction and sense. Therefore, force is a vector quantity. Do you know why we move forward when a car brakes? The answer is because of its inertia. Let's find out what it is. Aristotle states that a body can only move constantly if a force is applied to it. So, the moment it's no longer applied, it stops. Galileo Galilei
How was that? Better? Higher.
was the first to formulate the concept of inertia. He notes that on a smooth surface like ice, even heavy objects continue to move even after he stopped applying force to them, proving that Aristotle was wrong. So, why do objects stop? He discovered that other forces interact in a moving body, such as friction with the ground or air. He proposed that if an object moved in a perfect smooth plane, its motion would be ad infinitum. It means forever.
To infinity and beyond!
On the other hand, in the absence of force, an object remains at rest. For me, it is interesting how many years later, when space travel began, it was proven that Galileo was right. If an object or an astronaut receives a force, it will continue to move away forever, since there are no other forces in space. Galileo's principle of inertia established that, for example, this ball in the Firenze Stadium begins stop means that it's not receiving any force. But when this player kicks it, it will begin to move because he applied a force to it. The ball, when it comes in contact with the air and the grass, will begin to slow down to the friction. That is a force opposite to that of its movement. Isaac Newton was an English physicist, mathematician, philosopher, theologian, inventor, and alchemist. He is considered one of the most important scientists in history.
Genius, billionaire, playboy, philanthropist.
He continued with the work of Galileo and discovered that there is no absence of force. Rather, when an object is at rest, it means life. The sum of all its force is equal to zero. Let's look at this ball again. Just because it's not moving doesn't mean that there are not any force on it. There is a force pulling down, which is weight, and exactly equal but opposite force generated by the ground got up. They neutralize each other, causing a state that we call balance force. Now we have a ball in the Wembley Stadium. It is balanced, that is why it does not move. When the player kicks the ball, the balance is broken and the movement begins. That's called unbalanced force. The friction with the grass starts but doesn't stop the ball. It does not stop immediately, the ball seeks to continue in motion. Even though after a while the friction stops the ball and returns to balance. Then, Newton defined the inertia is the ability of bodies to oppose a change of state, whether rest or movement. Look at the boys in the image. The bus is moving forward. When the bus brakes, an opposite force is applied, but the passengers continue moving to the initial force of the bus. Just as the ball does not stop immediately due to the friction with the grass, the boys on the bus maintain forward movement or inertia. Okay, now we have here the second law, proportionality between force and acceleration. An object changes its speed if it receives a force. So, if a body is at rest, speed is equal to 0. And when a force is applied to it, the body increases its speed each time. And this is we call, yeah, that's right, acceleration. Now, if I push an object with more force, it would move faster. I have 3 supermarket cars here. Now, if I push it with the same force, which one will move more? Well, it's easy to determine that the car with less weight will move more. Then we can establish that the greater the mass, greater the force required to move an object. Newton established that the greater the force, greater the acceleration. But the greater the mass, the acceleration decreases. Observe what happened with the supermarket cars. The second only obtains a half of the acceleration, and the third car a quarter. Then the formula looked like this. Acceleration and mass are inversely proportional. That is, when a mass increases, the acceleration decreases. Now, this is how the formula looks like. Now we know acceleration is the result of an interaction of force with the mass of an object. But also force is the product of accelerating an object. So we move the formula like this. We remember that in maths, when we're talking about a product, we're talking about a multiplication. The units of force are as follows. Mass is measured in kilograms, and acceleration in meters per second squared. The system of measurement units, SU, defined that the measure of a force should be in the Newton. 1 Newton is defined as the force required to move 1 kilogram at the speed of 1 meter by second for a second. Now, it's time to go to the blackboard and make a demonstration of these two laws. We have here a force example. A force is applied to a 2 kilograms box and it reached an acceleration of 5 meters per second squared. What force was applied? First, we filled in the data. We have mass here and acceleration here. Okay. Now, for the procedure, we apply the formula. Okay, mass here and acceleration here. It's multiplying the acceleration by the mass. In this case, it's 5 times 2. So the result is that the force applied was of 10 newtons. Now, an acceleration example. A force of 20 newtons is applied to a 5 kilograms gym weight. What is its acceleration? The same. First, we fill in the data. Okay, we have force and we have mass here. Okay. Now, since what it asks for its acceleration, we must back to the formula.
Back to formula.
Remember, if it's multiplying, to solve it, we need to pass by dividing. We substitute the data into the equation. What happens to the units? Newtons, it's equal to kilograms. It's equal to kilograms per meter per second square. So, we have kilograms up and kilograms down, so they cancel each other out. Finally, the result is that the acceleration is of 4 meters per second square. To finish, let's go back to the cars and demonstrate what we had said. If I apply the same force of 2 newtons to them, see what happened. The first car obtained an acceleration of 2. The second car acceleration is the half, it's mean 1. And the third car acceleration is 0.5, which shows that the greater the mass, the lower the acceleration. With this we end this video. Thanks for watching. In the next chapter we will close with the Newton's third law.
Muchísimas gracias, doy clases los jueves, no cobro mucho.